Hello everyone, this is Akhil Reddy Cherukupalli. I have chosen the topic cloud-based network virtualization in Internet of Things with OpenStack. Network virtualization. So our virtual networking approach has like two forms, like the TCP and UDP. TCP is known as Transmission Control Protocol, and it has a throughput and latency performances by the native interconnection using the cloud-based instance and following with a public IP address. Whereas the user datagram protocol called as UDP, as like sending right is timely controlled, and we can able to inspect the behavior of the virtual networking design and scalability of the system. And then it also has a representational state transfer known as REST APIs, and it has many more advantages in it. And the network virtualization mainly has like two different types. They are like virtual local area networks and virtual private networks, and it has many different kinds forwarding plans like software defined networking known as SDN and network functions virtualization NFV known as. So these has many more advantages in it by having solving like typical challenges in today's database deployments, and also has a level of flexibility and scalability, and therefore it has like customization of networking topologies, and then the agility provided by the software based computing resources. Stack for things, it is arrived from the effort in infrastructure as a service from the Internet of Things cloudification. So it is mainly as a open source middleware for the infrastructure as a service cloud model, and it also has an OpenStack which fully matches the input output cloud paradigm. So this has approach as for the storage facilities, for the distributed IoT resources, and then it has hosted by different type of nodes, and it's deployed at the network edge. So it mainly deals with the different constraints of IoT deployments, such as nodes reachability, and then by using techniques based on the WebSocket, by having a mechanism like a reverse tunneling mechanism. We'll discuss this in the further slides. And then it has some three different types of functionalities. They are like tenants and projects. So in these, the SOT manages the authorizations for the users to access or manage the IoT nodes, which the resources must need to host there. And this authorization aspect achieved by the integrating a keyword like Keystone, which has a authentication service in the OpenStack with the middleware. And then we have remote access. In these, the administration has an access for the IoT nodes regardless of their network configuration by using a port forwarding mechanism on the cloud like we use in the UDP side. And then it has remote programmability, so it also enables the users to customize the business logic running in the IoT nodes by injecting a pluggable software components defined by the user. For example, like a pen drive, we inject that. Creating virtual networks through SOT has 5 different approaches. So the first one is seamless integration with OpenStack. So in these, the networking subsystem Neutron has fully compatible with OpenStack. Like we have the system Neutron, and then it has tenant based segregation, and it is considered as a strong built one by has an example of load balancing. It has value added services in the IoT context. And then it has virtual machines containers with overlaying network enables, and it enables two environments to collaborate in the cloud based instance. And then it has other approach called zero configuration networking. In these, so they have approach it doesn't require any specifically. So the edge routers or the networking equipment, it has same broadcast domains. So for example, and it has 2 to 3 VPNs based on the internet, and it avoids the manual configurations. And then it has other one mobility support. So in these IoT node experience a vertical handover, switching from 3G or 4G to Wi-Fi, or whenever we have Wi-Fi is down, we use the mobile network, we can switch the network from different like mobile connection to the Wi-Fi connection. It has like network virtualization, different like IP address and MAC address, and it has attached to the IoT node, and it has but like same overlay IP address. And then extended IoT networks. So basically the Linux based operating system has like with Python and the Node.js like as runtime environments, it has like several different runtime environments. So for example, a JavaScript enabled browser, it has like most constrained environments. Examples like mobiles, we have many applications in it, and it has like a different type of virtual network in it, and it has like Android based device, like we can see the stability of the virtual networks in it. And then efficient application development. So in these, by using the network virtualization capability, a developer can accommodate the IoT nodes to meet the application's networking topology requirements. So here S4T, it enables the programmability, like even at the runtime, like IoT nodes, a developer can upload anything to the cloud, like defining the business logic and by injecting it to an IoT node. So it provides a choice between like which one to use, like either Python or Node.js as suitable in those environments, as like for considering like which is the higher level programming, which facilitated the selection with the, it included the libraries and frameworks in it. So this is the architecture for the Stack 4 Things cloud side architecture. So in these, like the IoT nodes are hosting Linux based tools by using the different type of environments, and especially like running Python and Node.js required for the S4T node. And it mentioned as a Lightning Rod LR, and it has a like web application messaging protocol. It has represented over here. We can see in the L3 DHCP agent, L2 agent in the top, a network mode. And then it has remote procedure calls. It is between the cloud and the IoT nodes. And then it has like a Neutron subsystem. We can see on the left like Neutron server, all on the top ones. And then the bottom one is the S4T we are using right now. So basically it starts from the browser, and implementing the S4T dashboard, it goes to the IS4T software and the Neutron, and then finally they conclude with the virtual switch by implementing the red switch, the lightning rod one. So basically this is an OpenStack networking subsystem, that is Neutron. It's like a self-service system. Any cloud user can configure and customize the networking topologies here. And then it also deal with the provision like keeping like users traffic isolated when they use the same IP address ranges. And then it also mentioned like a network, subnets and ports in its terminology as Neutron. And then it has like a media access control, MAC, over in the we can see, and then it has like messages which has from the RPC sector. So in this slide we have two pictures. The first one is it regrouping the IoT nodes. So all the nodes like from different physical layers, like from the internet, the cloud, it's all working together as a virtual network, we can see over here. And then from the other slide we can see they all are connecting to the mobile, like how it goes through the mobile or any PC by using the internet and the IoT node. So in connection with the previous slide, now we are using a signal tower. We can see over here like how we are getting the net, like any network over from the network signal to the edge router, and then goes to the internet, and by the IoT it is going to the cloud by operating the virtual machines with the internet, and we are getting from the edge router to our smart mobile. So in these we can use like some of the methods like get, put, delete methods for the RESTful networking APIs which are used in the Stack 4 Things. We can see their URL and the semantics, like why they are used and their parameters for it, and what will they return in it. So basically this slide shows the difference between the uploading and downloading speed in it by differentiating the differences between the minimum, maximum, main and stdev. So we can see over here like uploading and downloading different by the S4T and the native. So here the package delivery distribution can be explained by the latency experience one by using the IoT node received from the TCP traffic from the cloud. So this table explains the packets of their payload, like what happens if they took like less amount and the excess amount by using the socket process and uploading to a cloud virtual machine with the different type of data sizes. We can see in the picture it displays the packets and the percent, like how many bytes, and the CPU usage depends on the number of bytes on it. Problem. This paper mainly resolves the problem like how to use network virtualization in the Internet of Things, and then it also introduced a new service called Iotronic, which is in compliant with the OpenStack middleware. Related work. In this paper, they took the reference from the paper SDN based virtualization platform, and they also took the reference from OpenStack extension, which is used for the personal service, and then the Neutron team developed a solution for the virtual networking by using the OpenStack. And also the fog computing paradigms like has the main service oriented infrastructure. It represents like preliminary tested and deployed on the same LAN to avoid the NATS traversal. Authors solved this paper by having a detailed report of the network virtualization approach for the Internet of Things deployments, and then they highlighted a technical implementation which has the differences between the standard cloud-based Neutron deployment and the Internet of Things oriented solution. Experiment. They have explained detailedly about the network architecture strategy for IoT installations, and then they has a clear point of view for the distinctions between the normal cloud-based Neutron deployment, and then they got our solution for the Internet of Things by using network virtualization. Results. In the S40 virtual network, they got of using WebSocket tunnels when traversing the firewalls, which doesn't allow through the packet inspection, and then by using UDP and collecting its data at the server side, they has a considerable packet loss by using the socket based overlay. Improvements. In my point of view, I'd like to expand the OpenStack cloud installations while taking containerization to the consideration. So I would like to also provide an essential service for the fog and edge deployments like a live container migration, and allow the migration for the IoT and the microservices. And then this goal can be achieved in a manner like it can't be affected by the other network configurations of the nodes in any other way. Reference for the paper. Thank you everyone. If you have any questions, please let me know through the discussion section.